Good afternoon, everyone, and welcome. My name is Lisa Gibson. I'm the managing editor of Ethanol Producer Magazine, and I'll also be your moderator for our webinar this afternoon titled Biofilm, a Hidden Threat to Ethanol Producers, and sponsored by Solenis. Before we get started here, we have a quick word from our sponsor.
Solenis is a leading global specialty chemical supplier and one of 3 companies with a truly global footprint. The company's product portfolio includes a broad array of process and water treatment chemistries, as well as state-of-the-art monitoring and control systems. While the Solenis brand is fairly new, the company is built on a rich history of several leading water and process treatment companies that have been in business for more than 100 years. During this time, the company has developed a number of game-changing technologies for the water-intensive industries that it serves. These innovations enable customers to improve their operational efficiencies, enhance their product attributes, protect their plant assets, and minimize their environmental impact. In an effort to help the fuel ethanol industry address its most critical challenges, Solenis has invested considerable time in developing an in-depth understanding of industry drivers and an understanding of the complex interactions involved in ethanol production. In addition to conducting extensive market and technical research, the company also leverages its global customer service network to gain insights into industry needs by initiating comprehensive conversations with customers through a novel blueprinting process. Ultimately, the data gathered is used to focus Solenis' research and development efforts on projects that will have the highest positive impact on the fuel ethanol industry. During the past decade, Solenis has developed a number of innovative technologies specifically for fuel ethanol producers. In fact, Solenis was the first company to develop corn oil extraction aids for use in fuel ethanol plants. Other recent Solenis innovations include a family of proprietary scale inhibitors that significantly reduces the potential for scale formation within evaporators while still meeting regulatory requirements, and a novel biofilm monitoring and control program that combines chemistry, equipment, and service to effectively address the threat of biofilm in ethanol plant cooling water systems. Solenis recognizes that the only way to ensure that these innovations can help its customers meet their goals is through a strong, well-trained field service team. The company has 3,700 employees and 37 manufacturing facilities, which span 118 countries and 5 continents. To learn more about Solenis, please visit the company online at www.solenis.com.
A big thank you to Solenis for sponsoring our webinar this afternoon. We have 4 panelists with us today. Tim Duncan, who is the application engineer for Solenis, Andrew Ledley, who is the marketing manager for Solenis, Jim Lauritsen, associate sales manager for Solenis, and Bob Jewell, who is the energy systems chief for Chippewa Valley Ethanol Company. To our attendees, if you have any questions during any of these presentations and throughout the webinar, you can go ahead and type them into the questions box on your screen, and at the end of all of our presentations, we'll have a quick Q&A session. So we can go ahead and get started here. Our first presentation features Andrew Ledley, who again is the marketing manager for Solenis, and who will also be accompanied in his presentation by Bob Jewell, who's the energy systems chief for Chippewa Valley Ethanol Company. Andrew and Bob, go ahead.
All righty, thanks very much, Lisa. Can you hear me okay? I'll assume that's a yes. So first of all, I just want to say thanks, Lisa. Thank you to BBI and Ethanol Producer Magazine for hosting this event. And a big thank you to Bob Jewell, who you're going to hear in a few moments. Bob is one of our customers. He's a fantastic customer. And you may have noticed that you've got 3 Solenis people and an ethanol producer doing the presentation. And I know that's a little bit different. Traditionally, when we host one of these webinars, we'll get other companies involved to maybe provide a broader educational experience. the story that you're going to hear this afternoon, we felt is really quite unique and compelling, and it was kind of best told by ourselves as a company, and with a lot of help from Bob Jewell at CVEC. So thank you for indulging us in this. It's unfortunately, it's probably necessarily commercial, more so than you might expect, but I think you'll find it pretty educational. So we're going to start off just talking briefly about how the perception of cooling water is changing in the fuel ethanol market. So in the preamble for Salinas, you heard that we have a process called blueprinting, which is a very rigorous process that we use to go out and talk to customers and really try to uncover needs and issues that are kind of being poorly met in the marketplace. And so we started this process well over a year ago. And one of the things that we uncovered pretty early on, and it was a little bit surprising, was issues around cooling water capacity in ethanol plants during the summer months. So some of the common bits of feedback we heard were something like this, that during the summer we just can't keep up. The cooling tower doesn't deliver enough cooling, and as a result, we're not making as much ethanol as we might do during the rest of the year, certainly on particularly hot days. Another comment that came up was we had plants that if they didn't own a chiller, they would actually rent a chiller during the summer just to give them, a sufficient level of cooling. And when you would ask an initial question around that, the typical response was, well, the cooling water is fine, it's just water. So there was something of an acceptance of the status quo of cooling water and cooling water capacity in ethanol plants. And we really wanted to challenge that a bit and try to go a little bit below the surface. So just as a starting point, I wanted to give you an example of what a 50 million gallon per year ethanol plant, if they were to experience a 5% throughput reduction during the 60 days of summer due to insufficient cooling, what kind of impact would that have on an ethanol plant? So you can see from the table at the right, how many gallons of ethanol per day. If you were to use $1.60 per gallon as a selling price for ethanol, you can see how much revenue would be lost for ethanol, for distillers grains, for corn oil. So you start to get to some significant numbers, over $850,000. And again, that's not based on a very conservative 5% reduction in throughput. The other thing to consider is that if you're running your cooling tower system inefficiently, just a 5% reduction in efficiency would actually cost you an extra $25,000 in energy, which is not a lot, but if this problem is persistent over the course of the year, it can add up. And as you're going to see later in the presentation, that $25,000 number actually isn't too far off the mark, and I think actually it's quite conservative. The last point we wanted to make was we recognize that carbon intensity is really important in this industry, and many plants are looking to get some incremental benefits. So again, with that, considering a cooling system that might be experiencing a 5% loss of efficiency, you get near a tenth of a point, a carbon intensity point, if you were to be able to address that problem. And again, this is an example with a 50 million gallon per year ethanol plant. So we're going to find out how you could be losing 5% or substantially more as we go through today's presentation. But we wanted to give one of our customers, Bob Jewell from CVEC, an opportunity to share his experience. Bob is quite unique individual. In my 26 years of working with customers, he's really inquisitive, and he had an understanding of biofilm and the impact on cooling kind of even before we started talking to him. So Bob, did you want to share some of your thoughts and experience?
Oh, yeah, thank you, Andrew. Can you hear me all right?
Yes.
Yeah, I think your numbers are that you just referenced on the previous slide. I think those are relatively accurate. Just to add to that, I think that in my opinion, the impacts of biofilm fouling generally is underappreciated, and I think that it's assumed that that type of biofilm fouling has a negligible effect on the process. throughput and cooling system efficiencies. I also don't think it's uncommon that that it's sometimes considered that biofilm is common in the system, and that not much needs to be done about it. So, you know, little emphasis is generally placed on understanding its impacts or addressing it.
Yes.
You know, that's just from my experience. It's something that's just seen as something that's normal at to the day-to-day operations. And it seems that, you know, the system as a whole, cooling water systems, are perceived as you know, very simple and requiring little in the way of diligent operations or control, and water quality control, as well as water treatment. You know, kind of like what you alluded to in the previous slide, that, you know, it's good enough, it's only water. You know, I think you hit the nail on the head there. You know, that's and that perception is, you know, I think is pretty common within the industry, but many other industries, you know, like power generation industry, they've left that perception behind decades ago. They've come to the realization that it has definitely has an impact on production.
Bob, that's a really good comparison. You know, the power industry has been around, you know, obviously decades longer than what the fuel ethanol industry has been in North America. So you're exactly right. I think years ago they identified, you know, biofilm as being an issue, and were probably more attentive to it.
Yeah, I agree. You know, and I think you know, just being the way that ethanol markets are, and the margins and everything, in that regard, I think ethanol plants, you know, as they strive to improve efficiencies and increase plant or production throughput and other things, it's driven more of the ethanol plants or ethanol companies to the realization that those perceptions are outdated, and it's leading them to scrutinize, you know, the costs associated with biofilm hauling.
Yes, yes. Well, I tell you, it's exciting to be part of the conversation. You know, the industry in general, in and of itself, is an exciting one to work in, and this particular area of it, I think we're really enjoying some of the conversations and some of the things we're discovering. Was there anything else that you wanted to comment on, Bob?
No, I don't think so, not at this point.
Okay, I know we're going to hear from you again towards the end of the call, and where you're going to share kind of some of your experience in the last few months actually addressing biofilm. So we'll definitely come back to you. Thanks, Bob.
Yeah, thank you, Andrew.
So I just have a couple of slides I wanted to share just to level set people, and then we're going to go into the technical part of the discussion for the afternoon. The first one is just for people that maybe are not as familiar with where cooling is used in an ethanol plant. You know, there's a number of different areas. You know, we've identified three of the, you know, the critical ones that most people might recognize. Certainly the mash coolers, where we're looking to take the temperature of the mash down, you know, pretty substantially from 145 to 90 prior to fermentation. You know, we know that yeast do not like to be, you know, boiling at 145 degrees. So for them to be effective at producing ethanol, you've got to get that temperature down. And then you got to maintain the temperature, and that's accomplished with the fermentation coolers. And we've seen this be a potential pinch point at some of the plants we've talked to during the summer months, where they're, you know, struggling to keep the firms cool enough. Another pinch point is around the ethanol condensers themselves, where you're actually condensing ethanol in the plant. It's not uncommon for plants to run chilled water to that application. So generally speaking, you've got cooling towers that are providing all of this cooling, or meeting this cooling demand during the year. But as we said at the beginning, it's not uncommon for plants to run a chiller maybe for 2 or 3 months during the summer, and particularly on the hot days. And again, that chiller oftentimes you'll be using on your fermentation coolers or in the condensers So just kind of coming back to Bob's comment a minute ago, you know, it's not just water that's in the cooling system. We wanted to talk just before we get technical, get you guys to think a little bit differently about cooling water. And the analogy we thought of was around fermenters. So, you know, everybody in an ethanol plant is pretty familiar with a fermenter and what it does. I mean, it's the heart of your plant. So if you think about it just from a microbial control standpoint, it's an environment where you're putting in nutrients and yeast where you want them to grow. It's an environment where you have the potential for bacteria to really have a negative impact on production. So you don't want to have bacteria, especially ones that make lactic or acetic acid in there. And you have limited treatment options. You can't just blast a fermenter with bleach or any other kind of a microbiocide because you don't want to harm the yeast. So it's a very complex living system. Well, cooling towers are actually not that dissimilar. You know, cooling towers are found where? Well, they're found out in the middle of cornfields as far as the ethanol industry is concerned. So you've got all that airborne dirt and debris and bacteria that get sucked into the cooling tower. And those bacteria can be very harmful, as you're going to see when we get tech talking in a minute. Bacteria can incite corrosion. They can reduce heat transfer. And you're actually, many plants are limited in what their treatment options are to control the bacteria. You're limited by your discharge permit, your NIPD's permit. You're limited by your FSMA considerations with the Food Safety Modernization Act. So again, very much like a fermenter, it is a complex living system. And so it needs to be treated with a fair bit of consideration if you want to get the maximum benefit out of your cooling system. So Lisa, we're going to hand the ball, I guess, over now to Tim.
Okay, yes, Tim, go ahead.
Hi, everybody. I hope you can all hear me. So we wanted to talk about the biofilms in general as a problem that's associated with your cooling tower that nobody really thinks about. I mean, we're all familiar with water treatment in terms of scale and corrosion, but as water treaters, we like to talk about the cooling water triangle. And it's really a combination of good corrosion control and good deposit control and good biological control. All three of them are interrelated. I mean, if you lose control of any of the three, you're going to have problems in the other areas. So just to zero in on biofilm, well, what is it? How does it get there? And what do we do about it? So as Andrew alluded to, you've got an ongoing ecosystem. You've got dirt and debris being scrubbed out of the air, and there's bacteria floating around in the air as well. I mean, that's how we get colds. And so as that gets sucked into the water, it's a nice, warm environment for these bugs to grow. And they're always there. And you can try to treat them in the bulk water, but that doesn't mean that they won't be in the inner workings of your system, deep down into the system. So if we start at time zero, after you've just dosed your biocide and you've killed all the planktonic bacteria that are floating around, within 20 minutes, because it's an open system and we're scrubbing new things out of the air, you've re-inoculated the water, and you start to see that stage 2, which is bacterial attachment. And what you want to prevent from happening is stages 3 and 4, which are biofilm formation, where you have an extracellular polysaccharide layer, or otherwise the goo. That's the byproduct of the bacterial respiration, if you will. And that can happen within 1 to 2 days. And then sometime later, you'll get a mature biofilm forming, which can cause you all kinds of problems with heat transfer, and we'll get into that a little bit, and some of the other problems that it can cause in terms of corrosion. And then later on, you'll see actual detachment of some of that goo that goes on and inoculates the rest of the system. So if you look at these little white bullets, these little rod formations in there, you can see that if you're measuring the planktonic bacteria, that's what we call those, that are floating around, that number really doesn't change in the first 4 stages. The stuff that you're measuring in the water is relatively constant until you get to stage 5, where of course you've got some detachment. So just monitoring what's in the water isn't necessarily telling you what's on the surface of your system. So how do we treat that? Well, traditionally what we've used is oxidizing biocides, and they work pretty well on the planktonic bacteria, but not so well on eliminating the biofilm itself. An oxidizing biocide is a blowtorch, if you will. It tries to burn everything that it comes in contact. And so it doesn't necessarily penetrate that extracellular or polysaccharide layer, or it gets burned up trying to penetrate it. And your choices are pretty limited in the industry based upon, as Andy talked about earlier, your discharge permit and what FSMA allows you to have in your plant, depending upon whether or not you're recycling your blowdown water back to the process. So biofilm can have a huge impact on your heat transfer versus, say, a mineral scale, which is what you're all real familiar with. But what you really need to understand is that, a thickness of biofilm is 4 to 5 times more insulating than the thickness of the scale. So 20 microns of biofilm can reduce your heat transfer by about 5%. If you think of that in terms of something we can all relate to, Scotch tape is roughly 58 microns thick. The glue is on Scotch tape is about 38 microns thick. So scale deposits are really visible, and you can see those. And you normally know that you need some hydroblasting or acid cleaning to remove them. And that's what you see. So when you open up your heat exchanger, there's no scale, so everything must be okay with my water. When in fact, you don't necessarily see a biofilm when you open it up, and that could be even more insulating than the hard scale. So it takes more energy necessarily to run your chiller if you're having to run a chiller, and so your carbon intensity is affected. You might have to run your pumps harder. You might have to run the fans harder. You've basically put an insulation blanket on your heat exchanger. To top that all off, these bugs can cause corrosion within your system. So as you build up a layer, you can see the surface there, the system has oxygen in the water on the outside, and some of these bugs use oxygen for respiration, and we call those aerobic. As you get deeper into the system, some of the bacteria are what we call facultative. In other words, they can use oxygen, or they can live in an oxygen-depleted environment. But the really bad ones are right down there at the surface, where there is no oxygen left, and they use other things for their respiration. And the byproduct of their respiration is typically an acid, and they're generated and at the metal surface where they're trapped now. They lower the pH, and they cause corrosion. And the kind of corrosion that they cause is pitting type corrosion, which is the worst corrosion of all, because while a generalized corrosion may be some, 4 or 5 mils per year, this is really concentrated, and it may be 50 or 60 mils per year, and you've got a pinhole leak. And one pinhole leak is huge because you get unplanned downtime, or you have to do some sort of repair. Heaven forbid it's in your heat exchanger, or now you're dumping mash into your cooling tower, and now you've got an even bigger problem. And to top it off, your oxidizers may not be the most effective way of going after that, because the oxidizers themselves can lead to a more corrosive environment, especially with with some of your systems that have yellow metals, like the tubes of your chiller. So how do we get into this thought of everything's fine, we don't really need to do anything about it, that Bob talked about? Well, we've got key operating indicators that we monitor, your routine testing. You know, we check the chemical levels, we check the balance of the hardness, we check the scaling index, we check the residuals on the oxidizers and our bacteria counts, and we look at it, and so everything's fine. So that kind of gives us a false sense of security. And the cooling tower doesn't seem to be falling apart. It doesn't look like anything's plugged up. And if I open up the plate frame exchanger, you know, I look at the cooling water side, and here's, you know, it doesn't look all that bad. Especially, you know, if I can compare it to the other side of that plate frame exchanger. So in that picture, you see the top side's the water, and the bottom side is the process. Well, the process looks pretty ugly because there's a lot of suspended solids from the mash. And that top side, you know, that just kind of washes off with a hose. I don't even really need to pressure wash that, so that can't be all that bad. So the key performance indicator on the cooling tower is really what we need to be looking at, not the key operating indicator, and that's really what you're trying to monitor. How much heat am I actually transferring, and how much corrosion do I actually have? And those can be monitored quite a bit differently. So if you look at this slide here, and this is actually a slide of one of our targets for our device that we'll be talking about in just a little bit here. And you can see that that's 250 microns of biofilm. And we wiped it away like it's nothing on the right half of the one picture. But that's 250 microns of biofilm, which is 10 times thicker than what's robbing you of 5% of your heat transfer. So you can see that, you know, if that was 10 times reduced in thickness, you might not even be able to see it. So you kind of get into this false sense of security, and what we really need to understand is how do we prevent this from being built up, and how do we go about monitoring it? It's deep down in the system, and we already said the routine testing doesn't really tell us much about that. So there's a way to ensure that the threat is detected and quantified and controlled, and we have some devices that are able to do that. We've kind of history that we have that we can tell you about these devices. And we call them our OnGuard series. It's a combination of hardware with sensors, flow regulators, heating elements, and custom algorithms, so that we're ensured that we're monitoring your critical heat exchangers exactly as they're designed, with the proper Reynolds numbers and shear stress, so that we have a side stream of your cooling water, and instead of having a heat exchange surface like one of your heat exchangers of millions of square centimeters, in one device we've got about 1,400 square centimeters, and in another one we've got about 350 square centimeters. So it doesn't take nearly as long for us to detect whether or not you've got a percentage of that foul. And so in real time, we get a view into the key performance indicator of your critical heat exchange. And as I was saying, you know, this OnGuard technology of ours might be new to ethanol, but it's not new to cooling water. We've got almost 40 years of experience with these devices, and it's changed throughout the years. And we started off with a heated rod and thermocouples and critical flow control and an annular surface, to monitoring to just deposits in a pipe, to adding heat to a surface with ultrasound sensing that we could detect scale, and now we can also detect 3 different types of fouling on a heated surface. And it's not just proven by us. We've sent this out to third parties to take a look at it as well. So it's an industry standard that's certified by some other folks. Can you back that up, Andrew? Yeah. So it's a whole suite of systems, and I guess the one thing that I forgot to talk about here before we went to the other slide was the OnGuard Online component of it. It's network-based, so that not only can you see it on site, but your field service representative can also look at it remotely and can send him alarms, and he can trend it, and we can get this data and provide dashboards that are useful. And it can be used for performance-based control, not just as a key performance indicator. Okay, go ahead. So the analyzer that we're talking about right now, the state-of-the-art one that's able to detect biofilm thickness and temperature differential, is the OnGuard 3D analyzer. We monitor the biofilm thickness and the difference in temperature across the heat transfer surface to come up with a true engineering fouling factor, and compare that to the bulk water temperature. And we also monitor the pressure and conductivity, because we have to account for the difference in the speed of sound as the water temperature changes, and the kinematic viscosity needs to be controlled, so we control the flow of the water as well. So here, before we start this video, I want to tell you how the thing works. So what you're seeing here on the left is the ultrasound sensor, and on the right is the heated target plate. And we measure the speed of the signal as it comes from the emitter, and how long it takes to get back to the emitter. And the difference between the time is the thickness of the device, of the actual deposit. So say, for instance, this green thing wasn't there, it would be hitting the bare steel substrate. Well, with the green thing in between, that's a film of some type. So go ahead and start it, Andrew. Nope.
Sorry, Tim. For some reason, it's misbehaving here.
That's all right. There you go. You got it.
There we are.
Okay. So now we see the signal, and it's sensing that we have a biofilm there, and the readout on the screen will show that we have a thickness of biofilm. And then if you look at the OnGuard Online, the dashboard showing that we've had a buildup. And now we can optimize by feeding a biodispersant or change our biocide dosage, and we can clean it up. And you can see that, you know, the chemical did feed and the thickness has gone down. And so it's unique in the industry in that it actually measures the thickness of the biofilm, not just tells you that you have some, and it actually can measure the heat transfer or the fouling factor. So we had this verified, as I said before, by the Karlsruhe Institute of Technology and the Center for Biofilm Engineering at Montana State University. And we've got some graphs here. This one from the Center for Biofilm. So the little red dots are along these graphs are where they actually took thicknesses and images, and those were at days 4, 6, and 9 of the biofilm. And the thermal insulation is the blue graph, and as you can see, the biofilm thickness is the dark blue, and they correlate perfectly as to thickness and insulation factor and what they saw under the microscope. And similarly, at Karlsruhe, they actually measured those with, I can't remember how the optical conical tomology or topography. That's what that OCT stands for. Anyway, it's a 3D image over about a 5 square centimeter surface. And the correlation wasn't exact because our biofilm detection is actually, you know, at a very focused point. So we're looking at maybe a millimeter, and they're looking at, you know, a much larger surface and giving us the average. But the correlation is still very, very strong. And we agreed that the thickness is within the margin of error of their ability to measure it and our detection. So Andrew's going to tell you a little bit about the findings that we've seen in the ethanol industry and some of the other industries, and describe how we've used it.
Oh, thanks, Tim. And that was a really good, I thought, explanation. You know, both of biofilm and of the device. You know, I know you've got 30 years of cooling water experience and expertise, and so it's really good to have you talk to the audience and kind of share some of those details. So I'm just going to talk for a moment about some of the initial findings as we've started to work with some of the ethanol plants in North America. The first one is that the model that Tim just shared, which is a kind of an industry typical model for biofilm growth, really does seem to be occurring in the ethanol plants that we've been working with. What we observe is when we put an OnGuard unit on the system to start up, it's, you know, typically we like it to monitor the current cooling water program, you know, as is. So in other words, no special changes to the program. And what we'll typically see is that, for example, the ORP, the oxidation reduction potential, is being used as a measure of how much oxidizing biocide is in the system, oftentimes chlorine. So we'll see that that level is within the normal range, and so there's an expectation that, well, that level's in range, so everything must be fine. But indeed, as 2 to 3 to 4 days go by, this is what we typically see. Biofilm is starting to grow in the OnGuard unit, and again, that's replicating what's going on in the system. So we're clearly seeing that, and we're also clearly seeing that there is a heat transfer efficiency loss as a result. And again, this is kind of despite just, you know, the normal biocide levels, ORP levels that, as Tim mentioned on one of the earlier slides, that's kind of a key operating indicator. The assumption is typically that if your key operating indicators in range, you're probably fine. And so this is one of the things that we're seeing that is quite common. The other thing that we're seeing, which is very interesting, and here's a specific example from a 10-year-old ethanol plant in North America. These are sections of the cooling tower piping system. So this is mild steel piping, and it's being replaced because of leaks. And so we have a metallurgical lab in Wilmington, and they kindly shared metallurgical samples with us. And when we put them under the microscope and we take off some of those corrosion sites, you can see very clear evidence of what Tim calls MIC, microbiologically induced corrosion occurring on the pipe. And then when you take a section of pipe and you chemically clean it to remove all that debris, you can actually see the devastation that occurs on the pipe. Those pits are what results in leaks, and it happens much more quickly than generalized corrosion over a pipe. So the pitting that we're seeing is well in excess of 10 mils per year. You can kind of see the little table on the bottom right-hand side indicating that if you've got over 10 mils per year of corrosion, you know, your lifespan of that piping is going to be 12.5 years. And, you know, most plants would have an expectation that the piping in their plant should be lasting a lot longer than 10 years. Certainly something like 20 to 25 years is not uncommon. So again, we've observed this at a number of plants that we worked with. So
thank you, Andrew, and thank you, Tim. Oh.
Nope, go ahead.
Sorry, Andrew. I was just going to take a moment to remind all of our attendees that if you have any questions, please type them into the question bar. Keep those coming in for our speakers. And our next speaker up is Jim Lauridsen, Associate Sales Manager for Solenis. So go ahead, Jim.
Thank you, Lisa. Can you hear me okay?
Yes.
Great. Again, my name is Jim Lauridsen. I've been with Solenis for 7 years. I'm the account sales manager for CVEC, and have called on Bob Jewell for almost 6.5 of the 7 years I've been with Solenis now. And I could share many stories with you about Bob and I, but I can tell you from the first time that I met Bob that even though we joke around a lot, we both take our jobs very seriously. I enjoy not necessarily selling chemicals, but providing solutions and value to my customers. I take pride in that and helping them solve problems. And I know that after talking to Bob for the first time that some of his key areas of job focus are number one, protecting CVEC's assets, improving plant efficiencies, which obviously equate to increased profitabilities. And those are some of the things that I think used to keep him up at night, but we've worked diligently over the years to improve upon those, and we'll continue to improve upon those. Bob had mentioned to me, I guess it was the latter part of last year, that CVEC was going to put in his new cooling tower, and he was very interested in anything new or improved that Solenis may have to offer for enhanced control or protection of his new system. And throughout the years, Bob and I have routinely discussed new product offerings, new technologies, any new monitoring or control equipment that Solenis might be coming out with, or that maybe some competitive company has come out with. And whether he'd have an interest or not in possibly evaluating those new technologies at his facility. And he always has, and we appreciate that. And as time went on, we really truly developed a transparent relationship and partnership where we could prove out these new technologies and new types of products, and then hopefully commercially roll them out to the rest of the ethanol producing industry. Coincidentally, around the same time last year, we were just introducing our performance-based monitoring control technologies to the ethanol market, and Bob was going through a little bit of a painful process of renewing his CVEC's NPDES permit. And as Bob is, he's an avid learner. He's a very early adopter. He likes to be first out of the gate for new technology. And Bob jumped at the opportunity to try some of the new offerings and basically partnered with Solenis. And during that process, we all felt that it was a perfect opportunity to get him off of his current bleach program and onto something more effective for microbial control. So at that point, we put our heads together and we introduced and then eventually implemented our Solenis Biosperse XD3899 microbial program, which has penetrating capabilities. It's a feed and control system, and we installed it, again, with the help of Tim Duncan, our applications team, and lab support. We teamed together and began running that on day one that the new cooling tower went into operation. I mean, at this point, this cooling tower that Bob fought tooth and nail to get was his baby, and it was my job to help him do everything he could do to protect his baby. And when I knew that we had the OnGuard 3B and some of our OnGuard monitoring and control equipment, I said, Bob, this is exactly what you need to wrap around this tower to protect it. And in the spring of 2017, earlier this year, after we put in the XD3899 microbial skid, we then brought in our OnGuard 2 Plus control system, which, as Tim had talked about, it's a real-time fouling and corrosion analyzer for cooling applications. Via SideStream, it enables us to basically model a critical heat exchanger or a condenser, and it also can monitor actual system fouling factors and corrosion rates, as well as other water parameters, if you will, like pH conductivity, temperature, and ORP. After the OnGuard 2 Plus was installed and operational, we then decided to bring in the OnGuard 3B biofilm analyzer, which in essence completed or closed the loop for a total cooling system monitoring and control program for Bob and CVEC's new cooling tower. Oddly enough, this past spring is when Solenis began to package this biofilm monitoring and control platform under our name, ClearPoint, Biofilm Detection and Control, which as you can see on the slide, it's a combination of equipment, chemistry, and service. So it's not just focused on one component. It's a combination of all three, and all three work together in order for this to be a successful program. It's not only focused on addressing biofilm, but preventing biofilm is part of your cooling water program. So in this particular case, with CVEC and Bob, you might call Bob I guess for lack of a better term, a super early adopter of the Solenis ClearPoint program, because we really hadn't technically rolled it out, but we brought it into his facility one piece at a time, and it proved its success, and I think we'll continue to see much more success and continued innovation at CVEC moving forward. I just wanted to share that with you folks in the audience, and at this point I'd like to ask Bob to possibly share some of his thoughts on the performance improvements that he's seen so far and what he's looking to achieve next.
Yes, I'm assuming everybody can hear me okay.
We sure can.
Well, thank you, Jim, for the kind words. I appreciate it. They make me sound a little better than I really am, though, I think. Yeah, I don't know. I guess regarding the OnGuard, or kind of like Jim alluded to, the ClearPoint systems are being utilized here to continuously monitor the system for biofilm growth, and it is assuring us that the XT3899 is controlling biofilm growth. As you can see from on the slide there, the graph on the right kind of represents one of a couple excursions that we had in the system where we did see some slight biofilm growth, and that was just due to ambient weather conditions. You know, they change here in God's country. They go from 60, 65 degrees, low wet bulbs one day, and the next day you're at 95 degrees and fighting cooling issues. So we had temperatures, weather conditions changed drastically, and had a little biofilm growth. You can see a little bump on the chart there, or on the graph, and the OnGuard systems indicated this while it was occurring, you know, giving us real-time measurements, and essentially enabled us to make adjustments and recover from that biofilm growth on the fly. So it works relatively well. You can kind of see in the picture on the right there as well. That is that represents the rod in the OnGuard 2 Plus unit, one of the two that we have here on site. And as Jim said, we put that unit online relatively soon after the cooling tower was started up, and we haven't really done any maintenance to that unit other than just accuracy or calibration checks on the pH probes and whatnot, and that heater rod looks just the same today as it did when we initially started that unit up. So I'm really impressed with the XT3899. And as you can see from that, the next bullet point there, the corrosion rates that we experienced in the system prior to going to the XT3899 system and having the OnGuard monitoring in place. Corrosion rates were averaging just between 5 and 6 mils per year. And you can see by the corrosion coupons at the bottom, the two bottom ones kind of in the center of that slide. We had localized corrosion or pitting. We got personally to assume that that's microbiologically influenced corrosion there. And then the other two slides on the right hand, or I'm sorry, the other two coupons that are represented on the bottom of the page there on the right-hand side are representative of corrosion rates today. So, you know, we have seen, you know, a drastic improvement in the corrosion rates, and it's not only improved, but it's consistent. We've had one other set of results since then, and you know, previously our corrosion rates were pretty erratic. You know, we'd see a 6 or a 7 mil per year, and then a 3, and but these are consistently down below 1. So pretty happy with that result as well. Regarding the copper corrosion, that next bullet point there on the left. In the past, we used an azole product for the corrosion protection, specifically for copper in our system, and that would be our chiller. When we went to get our NIPD's permit reissued, azole was not going to be approved as an additive for corrosion protection in our system due to its dose concentration toxicity. The XD3899 displaced that azole feed, and it has a lower dose toxicity. But even with the elimination of the azole product, the corrosion rates remain lower and more consistent than what we experienced in the past with the azole feed. So there's a number of benefits that we've realized here at CVEC. Previously, we relied primarily on close visual inspections of the equipment, often internal inspections of heat exchangers and plate and frame heat exchangers and whatnot on the cooling water system when they were taken offline. Relying on those inspections to check for biofilm, and you know that was problematic, you know, kind of as Andrew alluded to, or Tim alluded to before. You know, when you're talking about such a thin film that can impact the cooling efficiencies, it's kind of hard to appreciate the impact that they might have. We utilized dip slides to monitor the system for the presence of microbial growth as well. Currently, today we primarily rely on the OnGuard 3B to monitor the system, although we do still use the dip slides and perform some inspections, but we don't rely so much on those other methods as we used to. The OnGuard instruments are nice because it provides us with a model. You know, we can model that specific piece of equipment and draw on that OnGuard real-time in situ data to monitor for the presence of that biofilm at its onset and address it virtually instantly as it's occurring. So it's enabled us to be proactive rather than reactive in that regard. The OnGuard instruments also allow us to monitor for scale and corrosion. This allows us to optimize our inhibitor feed rates. It was, I believe, about a month and a half ago, 2 months ago, we started incrementally reducing our inhibitor dosage, the scale and the corrosion inhibitor dosage concentration and we reduced that concentration by about 10% to date, and have not experienced any adverse effects or seen any increase in fouling factors or heat transfer deficiencies. So the OnGuard systems are very helpful in providing that real-time data. It's really helpful to have that data, real-time data, available to you. Otherwise, you're putting corrosion coupons or stuff like that in place, and you leave them in for 30 or 60 or 90 days exposure in order to get some results that are relevant. You know, you don't want to take them out of the system too soon because you know, they're not acclimated to the chemistries that you're using. So essentially, with the corrosion coupons and that type of stuff, you know, you've got to wait a fair period of time in the manner of, you know, 2 or 3 months before you have good data that you can utilize. So you're kind of running blind for a period of time. But the systems that we have in place now, you know, they're really useful in validating saturation, stability, or scaling index models that some people might be familiar with. Those are models that are used to essentially model your system and determine what type of, or where you're going to run your cycles of concentration within the system, and avoid scaling indices and stuff like that. But this equipment can be used to validate that, you know, even when water qualities, say aquifer water qualities, change seasonally or in that regard. You know, so it's really useful to make sure that that your system is running optimally over the course of time. You keep going one more there, Andrew.
Okay.
As you can see by the slide there too, you know, we've achieved some pretty significant ROI with our new cooling water system. This slide here, the date on here is a couple days back. It's pretty similar, you know. I think the date here, I think we're about 55 hours on our chiller versus at this date for the prior 3 years, it's closer to about 650 hours. So we're on target for some significant reduction in chiller operating hours required. Much of that benefit is due to our new cooling tower, which was designed with excess capacity and lower than typical approach. The 3 degree Fahrenheit that's noted on the bottom of that slide is not something I think is real typical in the industry. I think somewhere in the range of maybe 8 or 10 degree approach might be more typical. But anyway, the clear point systems are our assurance that we're able to sustain that performance long term, and we definitely haven't realized any deficiency or any slip in that approach. Things are working very well to date, and hope that we can maybe have opportunity here in the future to provide a little update. Come back to the group and you know, come back in a number of months and kind of follow up and let everybody know how things are continuing. Any thought in that, with that, Andrew?
Yeah, I think absolutely. So first of all, thank you so much for sharing that, and your candidness and the folks at CVEC in terms of being willing to share some of this information. I think this is going to be really beneficial to the industry in a lot of ways, and certainly as you guys are trying to make sure that you're producing as much ethanol as possible with demand going up, and then with the focus on carbon intensity. We'll definitely look forward, Bob, to getting some more information and kind of publishing that out to the industry as well. I think you're really doing a lot to help the industry. So thank you very much for all of that level of detail. So just to wrap it up, a couple of points. I think from this talk, hopefully everybody that dialed in and gave us an hour of their time this afternoon got some value, got some education out of it. The perception is definitely changing in the ethanol market around cooling, and it's changing for the better. And so we're enjoying being, kind of a big part of that discussion. Biofilms are in fact a hidden threat in this industry, and it's not unique to the ethanol market, but it's gaining exposure in this market. So it's exciting to see some of those conversations happening. And then as Tim Duncan had shared with us, there is new technology available that allows you to detect, to measure it, and then control it and address that threat. So, I mean, with that, I want to thank Tim. I'd like to thank Bob, and I'd like to thank Jim Lordson for kind of sharing the story this afternoon. And again, hopefully everybody got some value out of it. So Lisa, I guess back to you. Thanks again for hosting us.
All right. Thank you, Andrew, and thank you all of our speakers. This is a lot of information for everybody. We do have a couple questions here, kind of directed toward the whole panel. So if you just kind of want to speak up, if you have an answer for one of these questions, go ahead and do that. Our first question is this biofilm problem likely affecting most ethanol plants just as an undiagnosed hidden problem?
The short answer is yes.
Yep, that was Tim, and I mean it's Andrew. I would concur. I mean we've spoken, I think, to enough ethanol producers now that it is a ubiquitous problem, I think, in the industry. That was a great question.
Anyone else want to weigh in on that before we move along to our next question?
Lisa, just to go a little further with that, it's undetected in the industry in general. The assumption has always been in all industry is that, if I've got enough chlorine in my water and my planktonic counts are good, then I don't have a biofilm. But we've known for a long time that you can't draw a correlation to that, and now we have a way of actually correlating and measuring biofilm in not only in general, but in real time. I mean, there's been a way of putting some type of a coupon in there in the past, and then waiting a few days and measuring the amount of biofilm that's actually on the coupon, kind of like the corrosion coupons that Bob was talking about. But by then it's too late. There's no real-time measurement. So I guess our biofilm detector is to biofilm what our sessile coupon is to what a corrator is to a corrosion coupon. So it's a way of measuring it in real time so that you can react to it.
Great, thank you, Tim. Our next question, what might make ethanol plants extra susceptible to this bacteria that causes biofilm, and why?
Tim, do you want to take that one?
Yeah, I guess I can. Bacteria need a nutrient source in order to grow. So in addition to, what you might see in a city, in a comfort cooling tower, the dirt and the stuff that's in the air in general, in an ethanol plant, you've got all kinds of good stuff right there. You've got your DDG storage and your wet drains, and then you've got your corn unloading, you've got a lot of nutrient there that the bugs need and love. And heaven forbid you have a mash leak or something along those lines. Now you've fed your system with even more nutrient. So that's one of the things that make them particularly susceptible.
Great, thank you. Well, that's all we have for questions today. Thank you everyone for dialing in.
Thank you very much.
A big thank you to Solenis again for sponsoring. And a quick note I want to share with everyone, our presenter, Andrew Ledley, today did write a contribution about biofilm and the Solenis solution to biofilm, and that'll appear in the August issue of Ethanol Producer Magazine. So everyone keep an eye out for that when we release that issue in the next couple of weeks. And one last note here, all of our webinar attendees do get an exclusive 10% off discount on exhibit space for Christensen's Biofuel Financial Conference coming up in September the 27th to the 28th in Minneapolis. And one last note, today's webinar was recorded and will appear on the Ethanol Producer Magazine website. That's ethanolproducer.com. A big thank you again to Solenis and to all of our presenters. And thank you all of our attendees for tuning in today. Have a good day.